Hello and welcome. In this presentation we will be looking at Karnaugh maps and how they may be used to calculate probability. Up on the left here is a description of how or what a Venn diagram is. Over here I have a description of the Karnaugh map. A Karnaugh map is another graphical tool that may sort the sample space into meaningful groups when there are two events. Very similar to the description of a Venn diagram. Just as a recap of a Venn diagram, we have a universal set which is within inside this rectangle. We have two sets in this diagram. Set A, all the elements inside that circle. Set B, all the elements inside this circle. We have A or B, which will be all the elements within this circle here, or that circle there. We have A and B, which are all the elements that are within both A and B, so it's just within this area here. And not A are all the elements that are outside this circle here. So let's have a look at a Karnaugh map. This number, or this question, is one that's been repeated from a previous presentation. Set A contains all the numbers which are multiples of 2, set B all the numbers which are multiples of 3, and there's a universal set which are all the numbers in the range 1 to 20. So I can say that there are 20 even numbers, 6 numbers which are multiples of 3, 3 numbers which are both even and a multiple of 3, and 7 numbers which don't match any of that criteria. Now let's look at the Karnaugh map. If I was looking for numbers which are multiples of 2 and a multiple of 3, I can say that there are 3. That there are these numbers here. You can see that entry there? They're both A and B. What about if I was looking for a multiple of 2 and not a multiple of 3? So all the multiples of 2 are in here. Well, the ones that are also a multiple of 3 are here. So I want to exclude those because I'm looking for not a multiple of 3. So I have a total of 7. What about if I'm looking at not a multiple of 2 and a multiple of 3? Well, all the numbers that are a multiple of 3 are within there, and I want to exclude the ones that are a multiple of 2, so I'm excluding these ones. So all I'm really looking at are the ones that are left over here, the 3. And what about not a multiple of 3 and not a multiple of 2? Well, there are 7. In other words, how many are outside the A or the B? I can add up these columns. So if I add up this column here, I can see that there are 10 which are a multiple of 2. 7 plus 3. How many are not a multiple of 2? In other words, how many are outside here? 3 plus 7, again, 10. I could go across this way. How many are a multiple of 3? 3 plus 3 is 6, or how many are in this here? 3 plus the 3, there's my 6. And how about not a multiple of 3? How many are not? It's adding up this row along here. Not a multiple of 3. So all of them in here, those there, are the multiple of 3. So the ones that are not are multiple of 3. There and there. That's the 14. I can continue adding up these here, and I end up with the total number of numbers that I was looking at. And it was 20, because I was looking at all the numbers between 1 and 20. Right, let's go and construct a Karnaugh map from this particular information here. Set A, set B. So how many are in A and B? Well, in A and B are just those there, so there's 2. How many are in A but not in B? Well, in A but not in the B is just that one there. Okay, how many are not in A but they're in B? So here we go, not in A but in B is, so I don't want to include the ones that are in A. They're not in A but they're in B, so it's just those 3 there. And how many are not in A, not in B? So here are all the ones in A and the B's. How many are outside there? Well, 7. Then I can add up my rows. Whoops. I can add up my columns. And my grand total. If I add up this way, I get 13. Going across this way, I get 13 as well. Let's move on to the next one. The next type of problem you may have to consider is completing this Karnaugh map. Some information's there, some is missing. Now, I can look here and say, well, 4 plus some number has to equal 10. Well, that would be 6. 1 plus some number equals 3. That is 2. Now, going across this way, I can say 3 plus some number has to equal 10. There you go, that's 7. Some number plus 2 equals 6. That will be 4. And the last one will be the 3. And if I wanted to use this particular information to calculate the probability, say I wanted to calculate the probability of A and B happening. So A and B will be this here. So there are 3 particular outcomes there out of a total possible of 10 outcomes. So I'll be looking for 3 out of 10. What about the probability of B? Now, B, how many are in B? That's there. That's the total that are in B. So that'll be 4 out of the 10. And what about the probability of not being in A? Well, let's look at the not A in the column. How many are not in A? There are 3. So there you have it. 3 examples using Karnaugh maps. I hope these examples have enhanced your understanding of working with probability. And until next time, have a good evening and good maths.